All right, so the only other new thing is that using simultaneous equations this time we're going to have them including quadratics, okay? So you'll get asked simultaneous equations probably in linear. These aren't really any harder. They're just a little bit more long-winded, and we might need to pause and use a calculator. If someone's got a calculator handy, that'll be good for the y values. Now, these ones are nice. You can see that both of them equal y to start with. So what we can do is we can just back the equations up against each other. If they don't, you're going to have to manipulate the equations to make them equal y, okay? Or that would be one way I would recommend doing it. So if they're both equal to y, what that means is that x squared plus 3x plus 8 equals 10x minus 2, okay? Because they're both equal to y. Yeah, definitely. Now, we'll start to pull this apart. We need this to equal 0, otherwise we can't solve it, okay? So it's a little bit different to the simultaneous equations that we've done before, because what we might try to do is we might try to use the null factor method in order to solve it if possible, okay? So we'll go and we'll take 10x off both sides. So I'm just trying to move everything left at this stage. Should have made that blue. And then I'll end up with minus 7x. And then I'll add 2 to both sides. So I'll end up with x squared minus 7x plus 10 equals 0. Okay, so now that I've got this, I can see that I'm going to be able to use the null factor method on this. So what I am doing is I'm going to factorize this, and I can see that if I start writing down my pairs of factors of the number 10, I've got 1 and 10, I've got 2 and 5, and that's going to work to make a 7, okay? Now, when I go to write this out, I know it's going to be a x something times x something. I'm having a little look at this symbol here. It's positive. If it's positive, that means that both symbols inside the brackets are going to be the same. So I go and look at this, and this tells me that they're both going to be negative. So I can fill that in. And minus 2 minus 5 makes minus 7. So I'm going to write that in. So that means that I've solved for x. X is 2 or 5. And now what I need to do, because remember it's simultaneous equations and it's asking me to find out what the coordinates are, okay? Not just what x is this time. So I need to find y, and I've got this choice. I can either substitute my x values into this horrible equation, or I can solve them by subbing them into the linear equation. Sub them into the linear equation. There's no way that you want to be mucking around with that horrible equation on the left, okay? So let's sub in. So we'll end up with the two possible solutions will be y equals 10 times 2 minus 2, which is 18, or we'll end up with y equals 10 times 5 minus 2, which is 48, okay? And then you guys can choose your own adventure. You can either write them as x equals this and y equals this, or remember what you could do is you could write them as coordinates as well. So you could have the coordinate 2, 18, and you can have the coordinate 5, 48. And then you're making it nice and clear to your marker that that's your final answer, okay, by underlining or highlighting something along those lines.
Does it matter which coordinates you go? Because you could go 5 and 18 and 28.
Definitely doesn't matter which order the coordinates are in, just so long as they're a pair of coordinates. Don't get lost along the way and somehow mishmash 2 and 48 together or something like that. Just keep it in a structure. So with this, I've sort of like worked down in rows just so I don't end up stuffing it up, if that makes sense.
Why can't you put 2 and 48 together?
Because you would end up with, I'll pause this for a second. Okay, so 2D, we've got simultaneous equations again that we're going to try and solve. At this stage, they both equal y, so that's great. There's no manipulating that we have to do yet at this point. So that means that if we amalgamate them, we've got 3x squared minus 2x plus 5 equals 3 minus 7x. And then I'm going to just start moving everything to one side because I have to make this equal 0, okay? So I'll add 7x's to both sides, and what I'll end up over here with is still got my 3x squared, and now I've got 5x's, and still got 5 at this stage equaling 3, and then I will take 3 from both sides, which means that now my equation that I'm going to start working with is 3x squared plus 5x plus 2 equals 0. Now we've got a problem, and the problem is this number here, okay? If all of those numbers were divisible by 3, in other words, if 3 was a factor of all those terms, then you divide the entire equation by 3 and knock it out, okay? The problem is that if you do that, you're going to have to start working with fractions, and that's not necessarily the easiest thing to do, okay? It can actually become quite painful. So if they're nice small numbers like this, just stay the course with what you normally do. Have a look at the number 2 and write down the factors of 2, because see, there's only 2 factors of it, which is quite good, okay? But when you go to write out your next line like we normally do, where it's going to be something times something equals nothing, one of those terms is going to be 3x, and one of those terms is going to be x. Stick with what we normally do next. Have a look at this little symbol here. It's positive, so we know that they're both either going to be positive or they're both going to be negative, and this one tells us that they're both going to be pluses. So we're filling it in, and what we're doing by doing this is reducing the amount of guess and check that we're going to have to do, okay? Now, if I have a look at the 2 factors that I've selected, 1 and 2, one of those terms is going to have to be tripled, okay? And this might make sense in a minute. But if I triple 2 and I add 1 to it, I'm going to get 7. That's not going to work. If I triple 1 and I add 2 to it, I'll get 5. Is everyone following me so far? It means that the 1 has to sit opposite the 3, and then the 2 sits in here. Because if we have a look at it, remember that we'll have 3x times x makes 3x squared. Then we'll have 3x times 1 makes 3 of these 5x's. 2 times x makes the other 2x's. And then finally, 2 times 1 makes this 2 up here. Does everyone follow how I've done that? Takes a bit of practice, okay? And sometimes it takes a bit of guess and check. Sometimes you got to just put it out, then expand it and go, no, that didn't work. And you're going to have to try again, okay? We will add surds to these at some point as well, and then it's ever so slightly more of a head bender, but we can get there. And then what we need to do is we need to solve this, okay? So remember that you guys, I'd noticed in the test, there were a few people who didn't quite catch this. When it's got 3 x's and a 2, then the solution is the second number over the first and the opposite symbol, so 2/3. Or remember, you can use the balance method to get there, or it's -1. And we're going to go through the same process again, but I think I'll probably hold us up here, okay, so that this doesn't go forever and ever and ever. But we're going to substitute the x's into the linear equation rather than the quadratic one.
Could you just use the quadratic formula?
You could use the quadratic formula, yeah, for sure. Yeah, I would stick to the null factor usually because I find it easier. but if you find the quadratic formula easier, unless you're directed to use unless you're directed to use one of the particular methods, you can use whichever one you want. Yeah. So I'll pause that. And here's some solutions. Yeah.